it was from something far, far bigger. Something of incomprehensible size.
I was blown away, totally, completely blown away. My God, what the hell are they seeing out there?
And the signals just kept on coming. Something out there was causing huge explosions, blasting out deadly gamma rays.
No one really knew quite what to make of it, and there were preposterous ideas bandied around for a while that even these were interstellar Star Wars going on, and we were seeing the phaser blasts that missed their target, or that comets were annihilating with anti-comets, or little black holes were evaporating. People didn't quite know what to make of it.
The journey that would one day lead science back into the cosmic dark age had begun. Astronomers were baffled. They had no idea what was causing these bursts. The most likely cause, they thought, was some kind of exploding star. But to be sure, they turned to no less an authority than Einstein, and to one of the most fundamental of all the laws of physics. E equals mc squared. This famous equation underpins many of our assumptions about how the universe works. It puts a limit on the size of any explosion. Nothing can explode with more energy than is contained in its mass. So, if some kind of star really was the source of these gamma-ray bursts, then E equals mc squared would tell you how big the explosions could be.
The amount of power you can get from a star is limited according to Einstein's famous formula E equals mc squared. And if we know m, the mass, which we do know for stars, then we know the maximum amount of energy which you could get by any conceivable process.
Once they knew there was a finite size to the explosions, they could then work out how far away they were. When they plugged in the numbers, they realized that these explosions must be happening in our very own galaxy. Any further away, and E equals mc squared would be broken. The explosions would be bigger than was physically possible for any star to produce. And so they scoured the galaxy to find out what kind of star could be causing these bursts of gamma rays. And before long, they thought they'd found the culprit. Neutron stars are amongst the most powerful objects in our galaxy. They are so dense that they have a gravitational pull of such strength that if anything strays too close, it is dragged onto the star with extreme force.
A neutron star is typically just a few miles across and will have a mass as great as the sun. So the densities are just enormous. If you dropped a marshmallow onto a neutron star, it would have the energy of an atomic bomb because the gravity is so powerful.
Neutron stars seemed to contain enough energy to produce these gamma-ray bursts. The only question was, what was actually triggering them?
There were a number of ideas relating to neutron stars specifically. The idea was you drop something onto the neutron star and it releases a lot of energy. One idea was an asteroid falling onto a neutron star.
It soon became the accepted theory that neutron stars fired off these bursts of gamma rays if something collided with them. The mystery seemed to be solved. Now they had the answer. Everyone began to speculate about the possible impact of these bursts on Earth. It began to dawn on them that if these explosions were coming from our own galaxy, in effect, they were occurring right next door to us.
If a burst did go off in our own galaxy, it would be quite spectacular. It would be extremely bright anywhere in the galaxy. And if it were close enough, I suppose it could do quite a bit of damage. Some people have hypothesized that major extinctions are the result of gamma ray bursts in our own galaxy.
While they worked out that the odds of Earth being hit again were extremely remote, if it did happen, the effects would be devastating. Bohdan Paczynski was an astronomer more interested in facts than the complex theories of the time. He decided to concentrate only on what he could actually see, the direction the bursts were coming from, and their distribution across the sky.
When I looked at gamma ray bursts, I realized, at least for me, it was hopelessly complicated. So I gave up on that instantly. I just thought it's far too difficult for me. And instead I looked at things, aspects of gamma ray bursts, which were easy to comprehend. And these are the distribution properties.
To plot the direction of the bursts, Paczynski turned to our galaxy, the Milky Way. When we look up at the night sky, we see the Milky Way as a narrow streak of stars. Astronomers call this area of the sky the galactic plane. But ours is a distorted view because we sit at the very edge of the galaxy. In fact, our galaxy stretches for 100,000 light years across space in a flat disk. If these bursts really were coming from within our galaxy, then Paczynski realized they should all be coming from just one place.
If gamma ray bursts were in our galaxy, they should be distributed the way everything is distributed in our galaxy, which means they should be near the galactic plane and possibly also concentrated towards the galactic center.
But when he pieced all the available data together, what Paczynski saw was something quite unexpected.
Gamma ray bursts were coming to us from all over the sky with no particular relation to our galactic plane.